Okay, hello everybody and welcome. Thank you for taking the time to attend this session. I feel very humble and honored to be here today to talk to you about how to build scalable web applications using microservices architecture and Node.js inside AWS Lambda. So the fundamental goal of every web application is to be up and run 24/7. But it's a huge challenge to do this at scale. And it can happen, failures can happen to anyone, right? No name calling today. Amazon CTO Werner Vogels keeps saying everything fails all the time. My 2 cents is that I don't know about your experience, guys, but it usually doesn't happen when you're in front of a computer in your office. Right. Vacation? Yeah, that's exactly what's going on. Does anyone else agrees? Okay, well, thank you guys. Well, my name is Eugene. I'm the technical partner at the startup based in New York, Mitoc group. I am developer. I'm working as a developer since high school. I'm worked for the last 7 years with AWS, going through all the phases, starting with the time when they launched the Amazon S3. I'm a certified solution architect, and I worked at companies like Amazon Web Services, Hearst Corporation, Grubhub, when it wasn't a startup. The company, Mitoc Group, is focusing on, we're an official technology partner, AWS technology partner, and we have featured AWS Lambda partners. Okay. So today, I'll try to explain you as much as I can a couple of major concepts. What is serverless computing? What is microservices architecture? And why Node.js is important in this ecosystem. So let's start with the serverless. What does serverless mean? Okay. In a nutshell, it's something involved with no servers, right? So to be precise, we as developers don't need to think about those servers, especially at scale. We get the access to services, right? And we're just using them as you would use your servers. But the best way to describe what is serverless, I like this guy. This is former Netflix chief architect, if you guys don't know, Adrian Cockcroft. And he says, if your platform as a service can efficiently start instances in 20 milliseconds and run for half a second, then you can call it serverless. Okay? AWS provides a large amount of serverless options, right? And just to make a point, can you guys raise your hand and keep it up if you're using Amazon S3? Now look around. Okay? So we've published last year a blog post and a couple of videos how to do it serverless on AWS, so I won't spend too much time. If you're interested, take a look. By the way, at the end, this is posted on a SlideShare. If you guys need some, feel free to take pictures, but if you need, don't worry, it's on the SlideShare. Now, serverless concept, there's a lot to digest in serverless. So why do we need additional extra concepts like microservices, for example? So to understand why, let me first go and explain what is microservices. Microservices actually is an architectural pattern, right, that helps with, that can be applied anywhere, either we're talking about infrastructure, or we're talking about a platform, or we're talking about the application, right? I personally like to think of microservices as a shredder for software that makes from a big and complex into a small and simple. But because it's a shredder, you get a lot of small pieces that if you'll take it manually to put them back together, you're crazy. Okay? So if it's software-driven, you can design it in microservices. Okay. Microservice architecture is also a very new trend that it gets most of us very excited, very eager to try it. And that's why it's so surprising that 2 years ago, according to Google Trends, this term didn't even exist. As a backstory, the guy that works inside the AWS Lambda team, before that he worked at Microsoft on the Bing team. And he told me, yeah, that's exactly what we're doing at the Bing, but we're not calling them microservices. Right. So finally, let's get to a hands-on demo. That's what I would like to show you and point out where Node.js plays a big role. Before doing that, I'd like to do an architectural review. Right? What does it mean to build scalable applications using serverless computing and microservices architecture? Okay? So all of these services that you are seeing here, there are 2, 4, 8, 9 services, and this is just the foundation. Right? And I don't have the SSH terminal to log in to try to manage my servers, and I actually don't need it. In my experience as a developer, prior to starting using this approach, I was spending 70–80% of my time dealing with something that is not applicable to application, mostly to our infrastructure, to the platform, and so on. So the request comes in, it goes to a DNS, right? The DNS resolves, it goes to a CDN. The CDN points to a hosting service, which a lot of people don't even realize that S3 can be used as a hosting service. Right? Then from the S3, you make calls to JavaScript. And I wish I would have this talk before Sarah. Now I have to say I'm on the dark side. Right? And so JavaScript makes calls to API gateway. And it also uses a service that is called Cognito. That's how Amazon helps you to secure and to ensure that everything that you do from the front end interacting with the back end is authenticated and is secured. Right? So you as a developer, you manage the security. Then it goes to an API gateway. API gateway is just a proxy, but it offloads a lot of the pain points of how do you set up RESTful APIs, how do you set up throttling, metering, and so on and so forth. And then it goes to the Lambda, which is the core compute service. It's just a container, a self-managed container service. Right? That's the backend, and then you can go to DynamoDB. DynamoDB is a great NoSQL or key value pairs database, but it might be very cost intensive at scale. Right? So that's why we have on the left, we are floating the reads to a caching mechanism like Elastic Cache. Well, sorry, I meant Memcache or Redis. And on the right, it's a queuing mechanism, right? Where for the use cases that you have the eventual consistency use cases, you can offload and get them into your database a couple of seconds later, maybe a minute later. It depends on the use case. Okay, so this is the architectural diagram. I will not be going into the whole code of these websites, and that's the websites that we are working on. But I'll show you a smaller application which is as relevant as this one. Okay, it's called to-do MVC. Right? So let me switch to the terminal. Okay, and let me switch actually to this one. So to do MVC. It's just we took the code, the front-end code from the to-do MVC repository, and we just applied to this serverless architecture using microservices. Serverless computing uses microservices architecture. So I'll just follow these steps. First step is to set up, right? All the prerequisites in order to be able to use it. Right? I hope you guys trust me that I already have installed DPFi on my local machine. And I just wanted to show you over here, the version. And this is the command line to streamline all the development, deployment, testing, and so on. Then the next step is just to try to install, well, not to try, but install it locally. Okay. So what it does, our DPFi command, it works with the repositories and with GitHub, and works with registries. Sorry, not repositories, with the registries. So it's successfully installed. Let me show you what it includes. It includes the code. It has the front end, the back end, the database setup, right? And it includes a deploy JSON file. Now, let's go back. To run it locally, or to run it in development, we're simulating locally everything. We're simulating the Lambda, which is just a Docker container on the local host. We're simulating the DynamoDB. It's just a local DynamoDB. That's how the package is called, AWS provides. And we're simulating the S3, which is basically a hosting service, your file system. There is nothing to simulate there. Okay? If you want to run it locally, just launch the server, and it does a lot of the compiling. Right? Because unfortunately, I don't want to specify the parameters. Okay. Now what you've seen, a dependency. Pull the dependency, okay? And mainly because Lambda doesn't support Node 6.6 that was announced today. The highest version that they support is 4.3. That's why we have a lot of complexity added into DPFi that compiles back, right, to 4.3. Okay? So while it's compiling, let me just show you what it looks like, right? I don't know about you guys, but that was blazing fast. And it's not because it's cached locally. It's because it uses a lot of the complexity of, well, a lot of the cool things like service workers that I used this website before, right? And what else? Sorry, never mind. So this is the website. I don't know if anyone used to do MVC before to build some of their capabilities or to show some of the, or to test it out or learn how to use I don't know, other JavaScript frameworks like AngularJS, React.js, and so on. But it's a very good tool to go get started. Right? Again, while it's compiling, just remember. So we as a team, we said we enforced ES6 standard, or EX 2016. 2016 or 2015? No, 2015. We imposed on our teams that will be using ES6 standard, right? And again, because Lambda is version 4.3, we need to use Babel to transpile that code in order to upload on Lambda. Again, while it's compiling, it will take a little bit of time. The first time, as you have seen, I started from scratch. It takes a little bit of time. Next iterations, because it just does NPM, we're using NPM on the backend. Because it does NPM update, it goes faster. There is a small inconvenience, aside that you cannot use Node 6.6, there is a small inconvenience in Lambda. If your code is big, the smaller is the code, the faster it works, right? So that's why another thing, because you do a lot of this transpiling and you generate a lot of the NPM, pulls all the dependencies as well, you want to optimize all of that, right? Either you're doing it by yourself, do it yourself, it's very easily, or you use, that's what we've done all of this work in order to pull the dependencies, to optimize, to make the package that is the zip file that is loaded on AWS Lambda as small as possible. And by the way, we're talking about scalability. We're doing this at scale. Right? So for the applications, the architecture that I showed you before, we have 120 microservices. Right? Imagine you start deploying all of this at once. Right? First of all, don't do it. Second of all, if you have to do it, just, well, do it once. You have to wait a little bit until everything is compiled from scratch. But then the iterations is just small changes to some of the microservices and pushing them live. Okay? Finally, it's done. And as you can see, it's localhost port 8000, and it runs exactly the same application. Okay? And just to, because I'm running a little bit out of time, sorry guys, the last step is deploying. It takes that, everything that you have compiled locally, it packages and it uploads it on AWS Lambda, but besides that, it's not just AWS Lambda. As you saw in the architecture, it's, I talked about 9 services that we're using. It pre-provisions the services, pre-provisions all the resources of the services, make them configuring the security, because we're using IAM, Identity and Access Management, to manage all the services. And by the way, it's secure by default. It doesn't work if you don't set up the security. That's how it works. Okay? So, let me switch back to the presentation. I would just like to call out this framework, which in theory it's a Node.js library, or a collection of Node.js libraries that deals with every service, every AWS service in an abstracted mode. It doesn't say go on S3 and take the file. It says go on the file system and take that file. Right? It abstracts you, so you as a developer, you can use it very simply. And if you don't know how to use those 9 services, you don't even need to know how to use them. It just, this framework does all the abstraction for you and offers it to you. Backend is a resource, make a call to get this resource. Front end, the assets, and so on and so forth. Okay? And yeah, last but not the least, we've done it on AWS, mainly because that's my experience. That's how I use it on a long time. If somebody is interested on helping out or is curious to extend it to other cloud providers, you guys are more than welcome to join us. Reach me out after that. Well, before I jump to questions, if there are any questions, I would like to point out that if you're interested, there are some code that we posted on GitHub that you can take a look. This SlideShare, this presentation will be uploaded on SlideShare. It is actually uploaded, but just the first couple of slides. The slides will be uploaded on SlideShare, sorry. And we have a couple of blog posts, and we keep posting about serverless computing, microservices architecture, AWS on the Medium. If you guys are interested, feel free to go there, read, and leave your comments. I'd like to thank Abby, and I would like to thank the team from Linux Foundation that put all this together. So I have 1.5 minutes if there are any questions. Yes? The question is if we are using CloudFormation. The answer is no.
Why?
The question is why we are not using CloudFormation. CloudFormation is a great DevOps tool, and we decided not to use CloudFormation because the pace of innovation on AWS is very fast, and even CloudFormation team is not able to keep up with all the other services team. So I knew that as a former employee, and that's why we decided not to use it and add another burden on developers to learn how to do CloudFormation. Right. Other questions? Yes?
How do you keep your API up to date documentation?
How do we keep our APIs up to date and the documentation? Yes, we're using Swagger, and we're using ES docs. So we're extracting all the comments from the code, which publishes automatically the documentation. So yeah, it's a good point. The documentation is docs.deep.mg. I'm officially out of time. Thank you very much. We appreciate it. If there are any questions, I'll be here. So.